Okay, we're going to be looking at the distance between 2 points on a graph. So as you can see, the point here, which is 3, 1, and this point here, which is -2, 4, the distance between this point to this line, the diagonal distance, is something that we can measure. We can measure using the Pythagorean theorem, actually. So what we're going to do is we can't really go, okay, this is 1 or 2 or 3, because the distance, the diagonal distance here cannot actually be measured because of course, you could see that these are not crossing at good points, right? So we can't really go, like, for example, if we had this line from here to here, right, we could say that the distance from this point to this point is 1 and 2 and 3, because from this point to this point we got 3 hops. We could say that. That's why we can do rise over run, because the distance of a straight line we can do horizontally and vertically, but we can't do a diagonal distance because we can't count it. You can't go, this is 1. You can't do that, right? So what we're going to do is we're going to go ahead and figure out how to actually, find the diagonal distance using the Pythagorean theorem, which is a pretty neat concept that we're going to do here. The first step is to take this line and turn it into a right triangle. And so how we're going to do that is I'm going to put a dot right here, and I'm going to draw 2 lines and make a right triangle out of it. One line I'm going to draw is right here. This one right here. Actually, I don't like this that much. Let me just go ahead and draw this point there, from here to here. And another one from here to here. You see that? And so what happened is I turned this diagonal distance into a right triangle. And from that, what I'm going to do is I'm going to count, because I can count the distance from the horizontal distance here is just 1, 2, 3, 4, 5. So that's 5 right here. And this is 1, 2, 3. And now I know that the legs of my right triangle is 3 and 5. And with that, I'm going to use a squared plus b squared is equal to c squared, and I can actually find this side, which is c. So one thing that I encourage you guys to do is turn this c into a formula, and the c can be, so if I square root, right, if I square root c squared right here, I'll get c. So let's go ahead and square root this whole thing on the other side as well. And this is going to be helpful later on when we're doing the distance formula for you to visualize what's going on. So a, we'll call this a here, 3 is a, and b is 5, okay? And so we'll do 3 squared plus 5 squared, and that would be 9 plus 25, right? And the square root is equal to c. So 9 plus 25 is going to be 34. And the square root of 34 is our c, which is going to be close to 5.8, 3, which is 5.3, and that's our answer. So we have figured out approximately the distance here from here to here, from these 2 points, is approximately 5.8. There you go. So this is a neat technique in using the Pythagorean theorem to find the distance between 2 points in a graph. It's a diagonal distance. If you had a vertical distance, you would simply count those points. But since you have a diagonal distance, you can use the Pythagorean theorem. Now the other thing on this one is that I want to show you is that if you decide that for whatever reason, let's say your graph didn't have enough room, you could have taken your points and you could have created a diagonal distance going above the line like this. So that could have been something you could have done. So there is no specific thing that says, oh, you have to use the bottom of the line. You could use the top of the line. So I could very well have used this green triangle here to figure out the distance for the diagonal distance that I want to figure out. So that would have been okay as well. So probably should have used the highlighter. That would have been easier to do. But yeah, so you could have done that if you wanted to. And or you could have used, so either this piece here, this triangle here, or of course we use the bottom triangle. So that's an important thing to recognize, and remember that you don't need to necessarily use the bottom triangle that gets created by this diagonal. You can use the top. Okay, let's do another problem here. Number 2, I'm going to give you guys some time to draw this out. Hopefully you have your graph paper. Your point here, this point is -5, 1. And this point here is going to be 2, 4. And you want to find the diagonal distance, this distance between these 2 points. Give you guys some time to draw this out. Okay, so once again, what we're going to be doing is drawing and creating a right triangle. So I'm going to go ahead and draw this line here right underneath, and this line here, and that will create my right triangle. And of course I know that this is a right triangle because it has a 90-degree angle there, right? And I know that from this point to this point I can count 1, 2, 3, 4, 5, 6, 7. So there's 5 here, right? And 2 more, that's 7, right? And from the vertical point is 1, 2, and 3. So we'll call A is 3 and B 7. So once again, we're looking for C, right? The diagonal distance, our hypotenuse. So we created a right triangle out of the diagonal line that we have. So A squared plus B squared is equal to, now I'm going to just take C and square root this. So this way I can kind of do a little shortcut with the Pythagorean theorem, and I don't have to do the square root at the end. Square root of 3 squared plus 7 squared is equal to C. That's 9 plus 49. The square root of 58. And that's going to be approximately 7.6. Okay, so C is equal to 7.6, and we solve for that. Great. I'm going to let you guys go ahead and look at the next question here and do yourself. See what you get. The first point here for number 3, this is going to be -3, comma, that's -3, 2. Okay, That's this point. And this point here is 1, sorry, -1, right? Comma 5. -1, comma 5. Oops, let me write this down again for you so it's a little neater. -1, comma 5. And -3, comma 2. So go ahead, and whether you want to create a right triangle above the horizontal line or below, it does not matter. In fact, I encourage you to go above it so that you get practice, your eye gets that practice of doing that. And then go ahead and let's see here. Go ahead and see what you get. We'll be right back. Okay, so what we went and did was drew our vertical and horizontal line to create a 90-degree triangle above the diagonal line here. The distance from the vertical line is 3, so we did 1, 2, 3 hops, right? That's 3. And the horizontal distance is 2, 1, 2 hops, right? So with that, we went ahead and found the legs of the right triangle, which is 3 and 2. Put in the formula, get square root of 13, and 3.6 is the diagonal distance. So this is equal to approximately 3.6. And some people write the square root of 13, so it's more, it's, you know, not an approximation, so it's an actual equal, exact equal distance. But if you are rounding, you can certainly use the approximation, which is little squiggly lines. Okay, so let's go ahead and look at the next one. You guys go ahead and graph this. Once again, this point on the bottom is 4, 1 to help you out on your graph paper. And this point here is -2, 4. So that will allow you for a better and precise graphing here that you could do. We're going to go ahead and let you guys finish this up. And we'll come back and check the answers. Okay, so this next question, again, we created a right triangle. I put it above the diagonal distance. So the vertical line came out to be 3, horizontal line came out to be 6. And we went ahead and put in the Pythagorean Theorem formula and got 6.7. Well, that's how you do that piece. Okay, we'll go ahead and do more examples in the classroom and practice some more. Thank you.